Welcome to part 4 of the video on trigonometric integrals. In this fourth video we're going to consider the last case of trigonometric integrals that are just tricky integrals that do not fit into any of the other cases. This is an example. We have the integral of sine of 2x over cosine to the fourth power of x plus sine to the fourth power of x dx. And the only guideline for this type of integrals is just use any true identity you know, and just hope you can simplify the integral. In this case we have here cosine to the fourth plus sine to the fourth. So what we can do is we can consider the sum cosine squared plus sine squared and square that sum. If we do that, we get cosine to the fourth plus 2 times sine squared plus cosine squared plus sine to the fourth. We do that because here we get the first term and the last term is what we have in the denominator of our integral. And we also know that this sum equals 1, just the basic tree identity. So 1 squared equals 1 squared, it equals 1. So we can solve for this sum, and we get that the denominator of this integral equals this. Here we have another true identity. We have that the denominator equals 1 minus 2 sine squared of x times cosine squared of x. And we also know that sine of 2x equals 2 times sine of x times cosine of x. So we can, using this, we can replace this expression is very similar to this one. So we get that 2 sine squared of x times cosine squared of x is sine squared of 2x over 2, because sine squared of 2x will be 4. Here we get a number 4 times sine squared times cosine squared. So we divide by 2. Now we're going to replace that in our integral. We're going to replace the denominator by the right side here. That will be 1 minus sine squared of 2x over 2. So we do that. We replace that. Here you have sine of 2x over this. And here we can do a little algebra to get that this equals this, and then take the number 2 out of the integral sign like this. Now we have sine of 2x in the numerator and sine of 2x also in the denominator. So you could think that this could be solved by substitution, and we're going to try to do that. We're going to make the substitution u equals 2x. That means that du over dx equals 2. We're going to replace that. We get sine of u over 2 minus sine squared of u. And here we can introduce the number 2 inside the integral again. So that becomes du over dx. Then we have that times dx. We can cancel the dx. This derivative is the number 2 here that we introduce again inside the integral. We can cancel the dx. We get this integral here. Now we're going to use again a true identity. We know that sine squared of u equals 1 minus cosine squared of u. So we're going to replace that here in the denominator. We get that the denominator will be 2 minus this expression, and here we get 2 minus 1, that's 1, and minus cosine squared, that's cosine squared of u. So our integral becomes sine of u over 1 plus cosine squared of u du. Now we had to solve that integral, and to do that we're going to make yet another substitution. You see why this integral is so tricky. There are so many steps. So we're going to make the substitution c. We're going to introduce the variable c that will equal cosine of u. That means that this derivative with respect to u, that is dc over du is minus sine of u. So we're going to replace in our integral. We have the denominator will become 1 plus c squared. Then we have sine of u that will be minus dc over du times the u. We can cancel this is sine of u, this derivative is sine of u. Now we can cancel the du and we get this integral. And this is a simple integral that you can find in your table of integrals, or simply realize that the derivative of arctangent of c equals this. So this integral equals minus arctangent of c plus c. So we have our answer in terms of the variable c, so we need to substitute back. First, we know that c equals cosine of u, but our original integral was in the variable x, so we need to substitute u also. And if we rewind, we'll find that u was defined as 2x. So this is our original integral, and we get the final answer to be minus here I forgot to put the minus sign, minus arctangent of c, and c equals cosine of u, and u is 2x. So we get arctangent of cosine 2x plus c. That's the final answer. A good exercise in derivatives is trying to verify that this is the correct answer. So that's all for now. Thank you for watching and see you next time.